Hey guys! Okay, so for today's video, we are going to be learning about how to calculate the magnification, image size, or even actual size of any type of biological specimen that you may see on an end of the year test. So a neat way we can do this is by simply using this chart over here where I have this cool little triangle. You can call it the I am triangle or the AIM triangle as long as you know where your letters go and how to manipulate those. Many of you have used a speed, distance, time triangle, and it works exactly the same way. So if we are finding magnification, a very important step is we're always going to measure our image size, but we will convert those most of the time to micrometers unless stated otherwise. And then this is the formula and how it's set up. So if we're looking for magnification, that means we're going to solve for image size divided by actual size. So M equals I over A. Magnification equals image size over actual size. Now, if we are looking for actual size, which will be fairly common, we will measure the image size, or they will give us the image size in a millimeter size. We must convert millimeters to micrometers, and to do this, we just simply multiply times 1,000, and then we will solve for actual size. So if we're using our triangle, actual size equals image size divided by magnification. So that's just a simple way to use this formula to be able to understand these problems. Now I have two problems drawn here on the board of examples of questions that you might see at the end of the year. The first question deals with a portion of the kidney as we see it under a microscope. So I have a depiction of the kidney here, and we're talking about in this question the glomerulus. It's one of the little filtering units, how our kidneys filter out the good and the bad in, in our body. So for this question, under a microscope, the kidney's glomerulus measures 35 millimeters. The magnification is 230. What is the actual size of the glomerulus inside of your body? So we know what it measures from the image that we're looking at. What is the actual size of the glomerulus? So the first thing we're going to do is convert 35 millimeters to micrometers. And to do this, we just simply say 35 times 1,000. Okay, so that gives us 35,000 micrometers. And the micrometer is always going to look like this M with a little tail on it. That's how you can decipher between a millimeter and a micrometer. Now, let's solve for our actual size. And I'm just going to use an A for actual size. That's going to be image size over magnification. So if we have our image size, which we converted to micrometers, we have 35,000 divided by our magnification, and that was 230. Okay? Now, if you have a calculator, this is where you would get out, have to do some calculations. If you're working at home, your cell phone should have a calculator on that. I've already done my calculation, and that's going to be 152 micrometers. Now, if for some reason your question asks you to transfer that back to a millimeter, you would just divide by 1,000, so that would give you 0.52 millimeters for that size of a glomerulus in millimeter form. But for us, we can say 152 micrometers is the size of your one glomerulus inside the Bowman's capsule of your kidney. Pretty cool. Okay, now we'll move on to another type of question that you may see where we're solving here for the magnification. So if you get a question about this, this is some sort of very, very small entity. For this, it's the red blood cell. And we want to know how many times is this question or this image that you're seeing, because you would see this on an image with a picture, either in a textbook or on a question. We want to know, like, how many times did this microscope have to magnify this for me to see what it looks like and see its features? So for a magnification question, your magnification, so M equals I over A. So magnification equals image size over actual size. Now, the red blood cell's actual size inside of your body, inside of my body, on average, is 2 micrometers wide. So the actual size of a red blood cell is 2 micrometers. So the image size of this, and I put RBC on the board, red blood cell, measures 9 millimeters. So the picture that you're seeing, so pretend this is the picture, and it's not right in front of you, but this is just how the video's got to work. The actual size of the red blood cell, of course, is 2 micrometers. What is the magnification? Now, the first thing we need to do is convert your 9 millimeter image into micrometers. So remember, we simply multiply 9 times 1,000, okay, which gives us 9,000. All right, now we are simply solving for magnification. I'm just going to say m equals. So magnification from our triangle is image size over actual size. So m equals I over a. Now my image size, which we have converted to micrometers, is 9,000 over the actual size, 2. Okay, because we get the 9,000 from our conversion, and then 2 micrometers. So if we wanted to put the units out beside it, we could. Okay, so our magnification, 9,000 divided by 2. Some of you can quickly spout that off. Some of you might need to go consult the phone calculator, the calculator nearby. 4,500 or 4,500. So the magnification, and you'll see when we have magnification, we put a little X after it because it means times. That red blood cell has been blown up 4,500 times for you to be able to see it in the picture. So those are 2 ways you can solve these problems. Thanks for tuning in.